Hello students, today we are going to study ninth lesson, ninth chapter, that is some applications of trigonometry, exercise 9.1. First question, a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. So we have given that a vertical pole and there is a rope tied from the top of the tower to the ground. Okay. Now that is we can draw a triangle ABC, right angle that B. And the angle made by the rope with the ground is 30 degree. It is given. Angle between the rope and the ground equal to 30 degree. Length of the rope equal to 20 meters. Length of the rope equals 20 meters. It is also given. Now we have to find the height of the pole. Okay. In triangle ABC, we have to connect opposite side and hypotenuse. Opposite by hypotenuse, it is sine, isn't it? So take sine 60 degree. Sine given angle is, sorry, it is not 60, 30 degree. Sine 30 degree equal to, given angle equal to 30 degree. Therefore, sine 30 degree equal to opposite side h by hypotenuse equal to 20. But we know that sine 30 equal to 1 by 2. 1 by 2 equal to h by 20. Now cancelling 2 and 20, here it is 10 times. Cross multiplying we get h equal to 10 meters. Okay, height of the pole equal to 10 meter. Therefore, height of the pole is 10 meter. Okay. Second question. A tree breaks due to storm and the broken part bends so that top of the tree touches the ground, making an angle 30 degree with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. That is, due to storm, a tree broken and bends to touch the ground. Okay, here this one is 90 degree. Take it, this is 90 degree. So a tree, it is broken and bent to the ground. Here x plus y is the height of the tree and the broken top makes an angle how much? 30 degree. 30 degree with the ground, isn't it? This is given. The distance between the foot of the tree to the point where the top touches, that is foot of the tree to top touches the ground. This distance is given as 8 meter. Find the height of the tree. That is, we have to find x plus y. Now we can name this triangle as ABC. It's a right triangle. It's a right triangle. In triangle ABC. In triangle ABC, first we can take opposite side and the adjacent side. Okay, opposite and the adjacent. That is, we can take tan. Tan 30 degree equal to opposite side x by adjacent side 8. But tan 30 it is equal to 1 by root 3, isn't it? Tan 30 is 1 by root 3. 1 by root 3 equal to x by 8. When you cross multiply, you get x root 3 equal to 8 or x equal to 8 by root 3. Now rationalizing into root 3, here also into root 3, that is equal to 8 root 3 divided by 3. Now next take sine 30. Okay, opposite side and hypotenuse we can connect. Therefore, sine 30 degree equal to, sine 30 degree is opposite side x by hypotenuse y, x by y. Sine 30 equals x by y. Sine 30 it is 1 by 2. 1 by 2 equal to x divided by, value of x is 8 root 3 divided by 3 into y. 8 root 3 by 3 into y. Cross multiplying, we get 3y equal to 16 root 3. Therefore, y equal to 16 root 3 divided by 3. Now, height of the tree equal to total height, it is x plus y. X plus y equal to 8 root 3 by 3 plus 16 root 3 divided by 3. 8 root 3 by 3 plus 16 root 3 divided by 3. 8 plus 16, that is equal to 24 root 3 divided by 3. After cancellation, we get 8 root 3. So, height of the tree equal to 8 root 3 centimeters. Okay. It is not centimeter, it is given in meter. So, 8 root 3 meters. Third question. A constructor plans to install 2 slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter and is inclined at an angle of 30 degree to the ground. Whereas for elder children, she wants to have a steep slide at a height of 3 meter and inclined at an angle of 60 degree to the ground. What should be the length of the slide in each case? So we can take the first case, that is for the children below 5 years. For children below 5 years. Okay. In that case, she prefers to have a slide whose top is at a height of 1.5 meters. So here, height of the slide should be 1.5 meters and is inclined at an angle of 30 degree. So it is inclined to the ground. This slide is inclined to the ground at an angle of 30 degree. And we have to find the height of the slide. A, B, C. Name the triangle as A, B, C. We have to find the length of the slide, that is x. So in triangle ABC, we have to connect the opposite side and hypotenuse. Since we have to connect opposite and hypotenuse, take sine. Sine, here the angle is 30. Angle of inclination is given as 30 degree. So sine 30 degree equal to opposite side 1.5 by hypotenuse x. Sine 30, it is 1 by 2. 1 by 2 equal to 1.5 by x. Cross multiplying, we get x equal to 1.5 into 2, that is equal to 3 meters, isn't it? X equal to 3 meters. That is length of the first slide equal to 3 meters. Therefore, length of first slide. Length of the slide equal to 3 meters. In first case, length equal to 3 meters. Now, second, for elder children. Second case we can take for elder children. For elder children, the height of the slide is given as how much? Height of the slide equal to, he wants to have a steep slide at a height of 3 meters. Here it is 3 meter, height equal to 3 meter, and length of the slide we have to find, take it as y, and angle of inclination is given as 60 degree. It is inclined at an angle of 60 degree. So slide is inclined at an angle of 60 degree with the ground. So here the angle is 60 degree. Take the triangle, we can take instead of ABC, we can take PQR. Okay, PQR. In triangle PQR, We have to connect opposite and hypotenuse. So take sine. Sine, here the angle is 60 degree. Sine 60 equal to opposite side 3 by hypotenuse y. Sine 60 equal to root 3 by 2. That is equal to 3 by y. Cross multiplying, we get root 3y equal to 6. Therefore, y equal to 6 by root 3. Now we have to rationalize it. Multiplying into root 3, we get 6 root 3 divided by 3. After cancellation, we get 6 and 3 cancels 2 times. So final answer 2 root 3. Okay. Answer is 2 root 3 meters. That is height of the second slide or length of the second slide equal to length of second slide equal to 2 root 3 meters. Okay. First one it is 3 meter. Second it is equal to 2 root 3 meters. Fourth question. The angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degree. Find the height of the tower. A tower, its height is not given, and from a point 30 meters away from the foot of the tower, the angle of elevation of top of the tower. From this point, the angle of elevation of top of the tower, it is 30 degree. Find the height of the tower. That is, we have to find h. Now take triangle ABC. In right triangle ABC, we have to connect opposite and adjacent side of angle 30 degree, isn't it? So take tan 30 degree. Tan 30 degree equal to opposite side h by adjacent side 30. Tan 30 it is 1 by root 3, that is equal to h by 30. Cross multiplying we get h root 3 equal to 30, or we get h equal to 30 divided by root 3. Now rationalizing into root 3 into root 3. That is multiply both numerator and denominator into root 3. Then we get it is equal to 30 root 3 divided by 3. Now cancelling 3 and 30 we get 10. 10 root 3. Therefore height of the tower equal to 10 root 3 meters. Okay. Height of the tower. Therefore we get height of the tower equals 10 root 3 meters. 10 root 3 meters. Fifth question. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. That is, we have given a kite is flying at a height of 60 meters. Height of the kite equal to 60 meters. And it is tied temporarily to a point on the ground. It is tied temporarily on a point on the ground. Okay. And it makes an angle of 60 degree with the ground. Here the angle of inclination equal to 60 degree. The angle between the string and the ground equal to 60 degree. Okay. Angle between string and ground equal to 60 degree. We have to find the length of the string. So take it as x. We have to find x. Right triangle, we can name it as ABC. Simple name, ABC. Now in triangle ABC, we have to connect opposite side and hypotenuse of angle 60 degree. So take sine 60 degree. Sine 60 degree equal to opposite side 60 by hypotenuse equal to x. Opposite side 60 by hypotenuse x. Sine 60 equal to root 3 by 2, that is equal to 60 by x. Cross multiplying we get x root 3 equal to 120 or x equal to 120 divided by root 3. Now rationalize it into root 3 into root 3. That is equal to 120 root 3 divided by 3. Now we can cancel 120 and 3. It is 40 times, isn't it? 40 root 3. Therefore, the final answer is 40 root 3. That is length of the string. Length of the string equal to 40 root 3 meters. Therefore, length of the string equals 40 root 3 meters. Okay.